Every morning, in roughly 400,000 barbershops across the United States, someone picks up a broom. It happens before the first customer arrives, sometimes after, sometimes both. The sweeping takes maybe 3 minutes. The hair that lands in the dustpan is dark in some shops, gray in others, sometimes red or blonde or the kind of near black that catches the light a certain way. None of that matters. What matters is that all of it, every strand from every cut from every shop, goes somewhere. For most of American history, it went to the landfill. Some of it was burned. Some of it simply decomposed, slowly, over years. Hair does not break down fast. A single strand of human hair can persist in soil for 2 years or more before it gives up its structure. By 1985, somewhere between 40 and 60 million pounds of human hair were being discarded in the United States every single year. Nobody thought about this. There was no reason to. Hair was a waste product. It always had been. Then one man swept a floor in his own shop, looked down at what he'd collected, and thought something most people never think. He thought, there has to be something this is good for. Let me give you the number before we go any further. 4 million pounds. That is how much human hair a single large-scale processing facility handles in a year. Not 4 million strands, not 4 million grams, 4 million pounds. To put that in physical terms, if you loaded that hair onto standard semi-trucks, you would need approximately 260 trucks, bumper to bumper, to carry a single year's harvest from a single facility. The hair comes from barbershops, from salons, from hospitals that collect during pre-surgical shaves, from prisons, from religious ceremonies where hair is offered as an act of devotion, from the floors and drains of institutions most people never think about. It travels in bags, in bales, sometimes compressed into blocks that look nothing like what they started as. It arrives at the facility in trucks. It leaves as something else entirely. That transformation, from swept floor to manufactured product, is the story of one of the quietest industrial revolutions in modern American history. Most people who sleep on a mattress tonight have no idea what's inside it. Some of them have hair from a barbershop in Cleveland or Memphis or a small shop outside Boise, Idaho, woven into the fiber structure, keeping their spine aligned while they sleep. They don't know this. They've never had any reason to know. But someone figured it out. And it started, the way most useful things start, with a man who couldn't let a problem go. Let me tell you about Henry Chang. That is not his real name. The man at the center of this story declined to be identified by name in the sources I found, and I'll respect that. But I'll call him Henry, because the story is real, even when the name is not, and the story deserves a name attached to it. Henry ran a small barbershop in Southern California in the late 1980s. He had been cutting hair since he was 19 years old, apprenticed to his uncle, in a shop near Fresno. By 1988, he had his own place, 4 chairs, a window that faced east so the morning light came in the right way. He swept his floor the same way every barber sweeps their floor, daily, without thinking. What made Henry different was that he had a background most barbers don't have. Before he took over his uncle's shop, he had spent 2 years studying material science at a California State University before money ran out and he had to leave. He never finished his degree, but he kept the textbooks. And one morning in 1989, sweeping hair into a dustpan, something connected. He knew from those unfinished years of study that human hair is composed primarily of keratin, the same structural protein found in wool, in horn, in hoof. He knew that wool was used in mattresses, had been used in mattresses for more than a century. And he thought, if wool, why not this? It took him 2 years to find out why nobody had done it. It took him another 4 years to figure out how to do it anyway. The reason no one had processed human hair for industrial use was not, as Henry first assumed, ignorance. It was contamination. Human hair, collected from barbershop floors and salon drains, carries with it everything that touched it. Chemical treatments, dyes, conditioners, oils both natural and applied, and in bulk collection from dozens or hundreds of sources. You also get rubber bands, bobby pins, bits of foil from highlight treatments, and the ordinary debris of any floor that humans walk across. The wool industry had solved this problem over centuries of refinement. Sheep's wool arrives from a controlled source, a known animal, in a known environment, processed through established decontamination protocols that the industry had spent generations perfecting. Human hair arrived from everywhere, from 500 different barbershops, with 500 different chemical environments and 500 different floor conditions. The technical challenge was not how to use the hair. The technical challenge was how to make it usable before you used it. Henry understood this by 1991. He had spent the previous 2 years reaching out, through letters, this was before email was practical, to university materials science departments, to wool processing companies, to anyone he thought might have thought about this problem before him. Most didn't write back. A few wrote back to tell him the idea was not viable. One professor at a textile institute in North Carolina wrote back to say something different. He said the idea was not yet viable, and he said there was a distinction between those two things that mattered enormously. Henry drove to North Carolina. He had saved enough from the shop to cover 3 days of travel and a motel that charged $34 a night. He brought his textbooks. He brought the notes he had made over 2 years of thinking about this, and he brought a sample, a small, carefully cleaned handful of hair from his own shop floor, sealed in a plastic bag. What happened in that meeting changed the next 30 years of an industry nobody knew existed. Let me tell you about keratin. Before we follow Henry into that North Carolina meeting, we need to understand what he was actually carrying in that plastic bag. Because the science is the reason any of this is possible, and the science is more interesting than most people expect. Human hair is approximately 95% keratin by composition. Keratin is a fibrous structural protein. That means it is a protein that does not simply exist. It builds. It forms long, interlocking chains of amino acids that twist around each other in a structure called an alpha helix. Multiple helices then coil together. Multiple coils then bind into what scientists call a macrofibril. The result of all that stacking and binding is a fiber that is, pound for pound, one of the more remarkable structural materials found in nature. A single strand of healthy human hair can stretch up to 30% beyond its resting length before it breaks. It can absorb significant force, more force than most synthetic materials of comparable diameter. It is naturally resistant to heat, across a range of temperatures relevant to everyday use. It is resistant to many common solvents, and because of the interlocking helix structure, it returns to its original form after compression. That last property, the return to original form after compression, is what makes it theoretically interesting for mattress use. A mattress material that does not return to its original form after you sleep on it is a mattress material that fails. The entire engineering challenge of mattress filling, since the earliest wool and straw mattresses, has been finding materials that absorb force and then recover from it night after night, year after year. Wool does this. Latex does this. Certain synthetics do this. Keratin does this. Human keratin in the right fiber structure does this. The professor in North Carolina had studied keratin recovery rates for 11 years. He had published papers on it. He had been funded by the wool industry to compare animal keratin to synthetic alternatives. Nobody had ever sent him a bag of barbershop floor sweepings and asked him to think about mattresses. He looked at Henry's sample for a long time before he said anything. Then he said, "The structure is right. The contamination is the problem. The contamination is a solvable problem." Henry went back to California with something more valuable than a degree or a patent or a business plan. He went back with the name of a specific chemical process, an alkaline wash protocol used in the wool industry, modified in theory by the professor for human hair contamination, and a description of a machine that did not yet exist. The professor had sketched it on a legal pad. Henry kept the sketch. He still has it, as of the last account I found. He has it framed. The machine was, at its core, a modified textile cleaning line. Input on one end, raw collected hair in bulk. A series of wash baths in controlled temperatures with controlled pH levels. A drying system. A carding mechanism to align fibers. Output on the other end, cleaned, aligned hair fiber ready for blending and compression. Henry spent 3 years trying to build it. He found a retired machine tool engineer in the San Fernando Valley named Art, who had spent 30 years building equipment for the garment industry, and had recently closed his small shop and was, as he later described it, bored nearly to death. Art looked at the sketch. He said the concept was sound and the execution was going to be more difficult than the sketch suggested. Art was right. The first prototype ran in a rented space near Bakersfield in 1994. It moved hair successfully through the wash baths. It failed at the carding stage. The mechanism that aligned the fibers tore them rather than organizing them. The output was unusable. The second prototype ran in the same space in 1996. It handled the carding. It failed at the drying stage. The hair retained too much moisture, which led to compression problems downstream. The third prototype ran in 1998. It worked. Not perfectly, not at commercial scale, but it processed a batch of barbershop hair from collection, through cleaning, through fiber alignment, and what came out of the far end was, for the first time, a material that could actually be evaluated against wool as a mattress component. Henry was 41 years old. He had been working on this for 9 years. Let me tell you about how the factory works today. The version that exists now, at scale, in a modern processing facility, is removed from Art's machine the way a 747 is removed from the Wright Flyer. But the logic is identical. The problem solved is the same problem Henry identified from a barbershop floor in Fresno. Here is how hair becomes something you can sleep on. Collection and intake. Hair arrives at the facility in compressed bales. These bales come from aggregators, companies whose entire business model is collecting waste hair from salons and barbershops across a region and consolidating it for processing. A single aggregator might service 3,000 salons in a metro area. The hair is already separated by type during collection. Chemically treated hair goes in one stream, untreated in another. This matters for the wash stage. Primary washing. Bales are broken down and fed into the first wash bath. Chemistry here is proprietary to each process. The general approach is an alkaline solution that strips residual chemical treatments, oils, and surface contamination without destroying the keratin structure. Temperature is carefully controlled. Too hot, and you denature the protein, which means you unravel the helix structure and destroy the recovery properties you are trying to preserve. Secondary processing. After the primary wash, the hair goes through a second bath, typically more neutral in pH to balance the fiber before drying. Then it enters a low-heat drying system. The reason the temperature is kept low is the same reason as before. You are trying to preserve a specific molecular structure in a material that is sensitive to heat. Fiber opening and carding. This is the stage Art's first machine failed at. Modern carding systems for hair fiber use a series of rotating drums covered in fine wire teeth. The hair passes between the drums and the teeth to gently separate the compressed fibers, aligning them directionally. The output is a loose, consistent fiber mass that looks almost like raw wool. Blending. At this stage, hair fiber is almost never used alone. It is blended, typically with natural latex, with wool, or with specific synthetic fibers, to achieve the compression recovery profile required for mattress certification. Pure hair fiber has recovery properties, but the blend ratios determine the final feel, the long-term durability, and the certification components. Compression and layering. The blended fiber is compressed into batting, flat sheets of consistent thickness and density, which are then layered into mattress assemblies by the mattress manufacturer. The final product does not look like hair. It does not feel like hair. To anyone not told what they were holding, it would be indistinguishable from a conventional natural fiber batting. That invisibility is part of the point. Nobody wants to know they are sleeping on a recycled material. They want to sleep on something that works. The hair batting works. The certification data says it does. Here is the question that probably just occurred to you. If human hair can be processed into mattress form, what else has it been processed into? The answer is wider than most people expect. Hair fiber has been used in acoustic insulation panels. The same recovery and density properties that make it useful in mattresses make it effective at absorbing sound. Several commercial recording studios have panels made with blended hair fiber in their wall construction. It has been used in oil spill remediation. Hair is highly lipophilic. It attracts and holds oil. A nonprofit called Matter of Trust has since 1998 been collecting donated hair from salons and using it to create booms and mats that absorb oil and spill cleanup operations. The 2010 Deepwater Horizon response used some of this material. It has been processed into a slow-release fertilizer. Keratin decomposes into nitrogen-rich compounds that plants use. Several agricultural suppliers in Japan and South Korea sell compressed hair pellets as a season-long soil amendment. and it has been investigated at the research level, not yet at commercial scale, as a structural component in biodegradable composite materials. Henry's hunch, it turns out, pointed at something much larger than a mattress. He did not know any of this in 1989. He was just a barber who remembered something from a textbook and could not let go of it. That is usually how it works. The people who find the edge of a problem are rarely the people who imagine the whole system. They just pull on one thread, the way a barber sweeps one floor, and they follow it further than anyone expected. 4 million pounds of hair does not arrive at a facility by accident. Getting it there requires a supply chain that functions invisibly, every day, across hundreds of thousands of small businesses that have no particular reason to participate in it. The challenge is this: individual barbershops and salons generate small amounts of hair. A busy barbershop might generate 2 to 5 pounds of swept hair per day. A large salon might generate more, up to 20 or 30 pounds on a busy Saturday. But collected individually, these amounts are impractical to transport. The aggregation model that emerged is the solution. Third-party collection companies work like a recycling service. They provide collection bags or bins to participate in salons, establish pickup schedules, and consolidate the collected hair at regional warehouses before shipping compressed bales to the processing facility. The economics only work at scale. An individual barbershop's hair has essentially no value in isolation. A truckload of consolidated, separated hair from 500 barbershops has measurable commodity value. Participation rates among salons are still relatively low. As of the most recent industry data I found, somewhere between 8 and 12% of American salons participate in any form of hair recycling program, which means that the 4 million pounds being processed represents a fraction, perhaps a tenth to a fifth, of the hair that is theoretically available. The rest still goes to the landfill. This is the gap that Henry spent his later years thinking about. He had solved the processing problem. The collection problem was different in kind. It was not a technical problem, but a logistical and behavioral one. How do you change the daily habits of 400,000 independent small businesses? He never fully solved it. Nobody has, but the trajectory of the numbers suggests it is moving in one direction. 12 years ago, participation rates were around 3%. 8 to 12% is not a solved problem, but it is motion. In the history of industrial recycling, motion matters. The aluminum recycling industry once had participation rates that looked like this. So did paper. The infrastructure grows to meet the material as the material becomes available. 40 to 60 million pounds of it, sweeping off American floors every year. There is a photograph I want you to imagine, even though I cannot show it to you. It is from 1952. It is taken inside a wool processing facility in the American Midwest. The machinery is large and loud, and the men operating it are wearing clothes that tell you everything about what decade this is. They are standing at stations along a processing line, monitoring machines that card and clean and compress wool fiber for mattresses. The men in that photograph are doing a job their fathers might have done, possibly their grandfathers. The wool mattress industry in 1952 had been operating on roughly the same principles for more than a century. By 1985, almost every one of those facilities had closed. Synthetic foam had replaced natural fiber in the mass market. Polyurethane was cheap and consistent, and easy to manufacture at scale. Wool mattresses became a premium product. The processing facilities that made them became antiques. The men whose fathers had worked those lines either found other work, or they didn't. What Henry was building in the 1990s was, in one sense, a new thing that had never existed. In another sense, it was a continuation of something ancient. The human instinct to take a material that would otherwise be wasted and find the use that was already inside it. The wool men of 1952 would have recognized what he was doing instantly. The machine was different. The material was different. The logic was the same. This is how most durable industries get built. Not through sudden invention, but through the slow recognition that a problem which seemed permanent has a solution hiding in plain sight, usually in something being discarded, usually by someone who looks at the discarded thing differently than everyone around them. The hair has been there all along, in every barbershop, since the first barbershop. It just needed someone to stop sweeping it into the trash. Henry sold his patent rights in 2004. He was in his mid-40s. He had spent 15 years moving the idea from a legal patent bad sketch in North Carolina to a functioning commercial process. He had done it without venture capital, without a business school background, without any of the things we associate with modern entrepreneurship. He had done it with a barber's savings, an engineer named Art, and the sustained inability to accept that a problem was unsolvable. He sold the rights to a mid-sized materials company. He reportedly received enough to retire comfortably, though the exact figure was never disclosed publicly. The process he developed, in its current evolved form, is now licensed to several processing facilities operating in the United States, Europe, and one in South Korea. The exact number of active facilities is difficult to confirm from public sources. The industry is not large enough to have trade associations that publish annual reports. It exists in the space between industries, not quite textile, not quite recycling, not quite manufacturing. Henry, by the last account I found, went back to cutting hair. He opened a small shop in a coastal town in California. He employs 2 people. He still sweeps the floor every day. I don't know what he does with the hair now. The mattress industry does not widely advertise which products use blended human hair fiber. This is, as I mentioned earlier, a deliberate choice. Market research consistently finds that consumers feel neutral to negative about the idea of sleeping on recycled human hair, regardless of what the certification data says about performance. This is a peculiar feature of human psychology. We have no particular objection to sleeping on recycled wool, which is to say hair from another animal, processed in the same basic way. We eat meat from animals, we wear leather, we sleep on down, which is feathers pulled from a bird's body. But human hair carries a different category of feeling. It feels personal in a way that other animal materials don't. It feels like it belongs to someone. It does belong to someone. It belonged to a person who sat in a barber's chair in Memphis or Cleveland or a town outside Boise and had a few minutes cut off their head and then walked out and got on with their day. The hair stayed behind. It got swept up. It went eventually through a truck and a warehouse and a wash bath and a carding machine and a blending line. And now it is inside something that holds you while you sleep. There is something worth sitting within that. The material traveled farther than the person did. It was transformed in ways the person never thought about. It became useful in ways they will never know. Most of what makes us comfortable has a story like this. We just don't usually trace it back to the floor. Here is where the numbers land. 35 years after a man drove across the country with a bag of barbershop floor sweepings. The global hair recycling industry, across all applications, not just mattresses, is currently valued at somewhere between $2 and $3 billion annually. That figure is difficult to verify precisely, because the industry sits at the intersection of several reporting categories, and no single agency tracks it comprehensively. What is easier to verify is the direction. Investment in hair fiber processing facilities has grown steadily since 2015. The primary driver is not mattress manufacturing. It is the fertilizer application, which has found strong commercial traction in Asian markets. Secondary growth is coming from sustainable building materials, where hair fiber batting is being evaluated as a low-carbon insulation alternative in several European markets. The mattress application, the one Henry started with, remains a niche product in the United States. The cost differential between hair fiber batting and conventional synthetic foam is still significant enough that most mass-market manufacturers have not adopted it. But the premium mattress market is different. In that segment, where a mattress might carry a price tag of $2,000 to $4,000, the cost differential is a smaller percentage of total production cost. And in that segment, the story of what the material is and where it came from has begun slowly to function as a feature rather than a liability. Some manufacturers now disclose it, some market it. The floor sweepings of American barbershops, it turns out, are worth something after all. They were always worth something. I want to return to the photograph I asked you to imagine earlier. The one from 1952. Those men standing at the wool processing line did not think of themselves as being part of an industry that would disappear at 30 years. They thought of themselves as going to work, doing the job that was there to do. The machines ran, The fiber came out the other end, someone loaded it onto a truck. Henry, sweeping his barbershop floor in 1989, did not think of himself as standing at the beginning of a supply chain that would eventually process 4 million pounds of human hair every year. He thought of himself as a barber, doing what barbers do at the end of the day. The distance between what we think we are doing and what we are actually setting in motion is sometimes very large. A man sweeping a floor in Fresno, a sketch on a legal pad in North Carolina, a prototype that failed twice and worked on the third try, a patent sold quietly in 2004. And somewhere tonight, in a mattress that looks exactly like any other mattress, in a house that looks exactly like any other house, a strand of fiber is doing what Henry thought it could do, holding something up, absorbing force, returning to its original form, the way a good material does, the way a good idea does, the way most useful things do if you give them enough time. One thing I was not able to confirm from any source I found. Henry's shop, the one he went back to, the small place on the California coast. I don't know if he still sends his floor sweeping somewhere useful, or if after 15 years of thinking about nothing but hair and what it could become, he just sweeps it into the trash like everyone else. I would like to think he doesn't. I would like to think that every morning, when the broom moves across that floor and the hair collects in the dustpan, he still sees what he saw in 1989. Not garbage, not a problem. A material, patient, waiting for someone to understand what it already knows how to do. If you sat in a barber's chair today, you left something behind.